Welcome everyone. I'm your host Dr. Yasir from Olympian Water Testing, an exclusive New York City and New Jersey based water testing company in the United States. My today's video will try to update your understanding on an important inorganic drinking water contaminant, that is aluminium, which is a heavy metal and occurs abundantly in earth crust. At small concentration, the element has been reported less to non-toxic to humans, but its higher exposure levels can cause health issues. Talking specifically about drinking water, the detected aluminum levels in drinking water are usually low and not considered a major health concern. However, controlling and monitoring the levels of aluminum in drinking water is very important to prevent high levels of exposure to aluminum and avoid any possible health risks. My today's video will help you develop better understanding on drinking water aluminum contamination, in which I will describe you some major routes of drinking water aluminum contamination, its regulations, health risks, detection and removal approaches to keep your water safe from aluminum toxicity. I will be covering the following contents in this video. Firstly, I will give you some background information on aluminum contamination in drinking water, major sources through which aluminum can enter in the drinking water systems and contaminate it. Next, I will update you on the regulatory status of aluminum in drinking water in the United States, including MCLs set by the authorities such as EPA. This will be followed by a brief description on various health impacts associated with aluminum exposures. I will then update you on some known quantification or detection approaches of aluminum in drinking water and various recommended methods for aluminum removal from drinking water to make it consumable for humans. Finally, I will give you some recommendations to keep yourselves and families safe from drinking water associated aluminum exposures. Coming to background information on aluminium, it is the most abundant metal in the Earth's crust and exists in the environment in various forms. The element is non-toxic to humans at small concentrations, but its higher exposure levels can cause health issues. Aluminium can be present in drinking water because of natural sources or human activities. It is important to mention that even though the detected aluminum levels in drinking water are usually low and not considered a major health concern, however, controlling and monitoring the levels of aluminum in drinking water is very important to prevent high levels of exposure to aluminum and avoid any possible health risks. Aluminium can contaminate drinking water in different ways, including both natural and anthropogenic. Naturally, aluminium can leach down from soil and rocks into the groundwater, whereas human activities comprise industrial or agricultural activities, mining, refining, and manufacturing processes, etc. Drinking water contamination of aluminum from both natural and anthropogenic sources can contribute to its adverse impacts in environment as well as humans. Talking about the regulatory status of aluminum in drinking water, in the United States, aluminum levels in drinking water are regulated by the EPA, which has set the SMCL of 0.05 to 0.2 milligrams per liter in drinking water. The SMCLs are non-enforceable standards that are based on the taste, odor, and color of the water. According to the EPA, drinking water at most places meets the SMCL of aluminium and contains very low aluminum levels in drinking water. For bottled water, FDA has set an MCL of 0.2 ppm for aluminium. More details on certain SMCLs, including aluminium, can be found by visiting the shared URL of EPA, where you can find the up-to-date details on limits of various chemicals, including aluminium, in drinking water. As mentioned, chronic exposure to high aluminum levels may trigger health issues in humans, mainly including neurological impacts such as memory loss or confusion. Some studies also support the evidence of an association between long-term aluminum exposure and Alzheimer's disease. Other health issues include kidney problems, which may also increase the risk of developing bone diseases. It is believed that infants and children are more susceptible to aluminum toxicity compared to adults because of the developmental stages, which makes them vulnerable to toxic exposures as the enzymatic machinery to catalyze the detoxification processes are poorly developed, causing accumulation of aluminum in the body tissues. Further, high aluminum exposure to infants and children may also affect their growth and cause developmental problems. Respiratory problems such as lung irritation and fibrosis can also be caused due to aluminum toxicity. In addition, overdose of aluminum provides oxidative stress in the brain, liver, and kidney, resulting in various associated diseases. Therefore, aluminum levels in drinking water should be monitored on a regular basis, and in case high aluminum concentration are detected in drinking water, it should be subjected to a suitable water treatment process in order to keep its level below the MCL and ensure safe drinking water supply to the consumers. It is very important that your drinking water should always be tested from qualified and experienced experts for accurate and reliable results. Aluminum can be quantified in drinking water using various described methods. Standard methods recommend the atomic absorption spectrophotometry AAS-based methods, which include FAAS or GAAS for aluminum quantification in drinking water. This method is cost effective with high sensitivity and low detection limits up to ppm level with high precision. However, if high sensitivity is desired, inductively coupled plasma ICP is considered the most effective method when coupled with mass spectrometer or OES to give results up to microgram and nanogram levels. Furthermore, ICP is also preferred where aluminum concentration need to be measured for human biological samples such as blood and urine, etc., since these matrices contain very low amounts of aluminum. However, the limitation of using ICP includes expensive costs to quantify metals and should only be recommended when the desired results are at very low concentrations. Ion chromatography is also a very effective method for quantification of ionic species of aluminum. The method separates aluminum ions from other ions in water by passing a sample through a column filled with a resin bed that binds and separates aluminum ions from water. Other commonly used methods for aluminum detection include colorimetry, in which colored complexes of aluminum are formed when a reagent is added to a water sample. Several methods have been proposed for efficient aluminum removal from drinking water. Among widely used methods include reverse osmosis, which uses a semi-permeable membrane to pass through water with pressure, resulting in the removal of aluminum in drinking water. At a small scale, distillation is also very effective in removing aluminum by heating water to generate steam, followed by cooling that results in the removal of aluminum from water. The ion exchange method using a resin bed of ions that results in the exchange of ions in water also removes aluminum from the drinking water effectively. Electrocoagulation is also used for removing aluminum from water, which uses electric current to coagulate particles in water including aluminum ions and separate them from water. Moreover, the coagulation flocculation method using chemicals such as aluminum sulfate coagulate aluminum particles in water forming flocks is also a very cost-effective and routinely used method for aluminum removal from drinking water. A routine monitoring of drinking water in your house and workplace from certified professionals is highly recommended. In case any aluminum levels are detected in your drinking water, it is highly recommended to remove its contamination using a recommended removal strategy. Further, you must ensure to trace and mitigate various sources that can potentially contaminate the drinking water system of your house and workplace and make sure to replace or clean the water pipes and plumbing every 5 years. This is all about my video on aluminium in drinking water. I am hopeful that the content of my video will greatly help you understanding basic concepts on drinking water contamination of aluminium, its associated health impacts, and how you can avoid or reduce aluminium exposure in your household drinking water. However, if you still have any query, please don't hesitate to reach us at the following telephone numbers and we will be pleased to respond your queries. Thank you very much and goodbye.